Hey guys, welcome. We're going to do another topic. It's still review. We're in review mode. We have an AP exam coming up. So I sent you guys the details on that AP exam. I'm not sure the formatting of that exam. We got 45 minutes. I don't know if it's going to look like this, guys, because then that would be three free response questions. So we don't know. It could look like this, or it could be many small free response questions or whatnot. So we're just gonna have to wait for April 3rd. Let's not assume anything. So let's just keep reviewing and let's keep doing Math Live. All right, guys. So let's get started. And so let me get my laptop situated, and then we'll start. All right, here we go, guys. Let me know if I make any mistakes. I make mistakes all the time. I just do one iteration of them, and whatever happens, happens. You can find the rubric online on College Board. Just Google 2016 AP scoring guidelines, and you'll find them. And you can compare my work to the scoring guideline. So let's go ahead and get started. This is your typical differential equation problem from 2016. It says, consider the differential equation dy dx equals y squared over x minus 1. All right, that's cool. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So you've done this many times, guys. So we're just going to go ahead and just literally just put little segments of what the slope would have been at those points. So the first thing I notice is that I have y at the top, or it's a y squared. And I know that 0 divided by any number, as long as it's not 0 on the bottom, is going to be 0. So that happens on the x-axis where the y value is 0. So I'm going to put a slope of 0 there and a slope of 0 there. Do not put anything at 1, 0. There is no lattice point there. So do not, guys. Don't even, just do the points that they give you. So the next point that I'm going to do the 2, 1, and I'm literally just going to plug in. So 2 is an x value, 1 is a y value. So let's see, 1 squared is 1, 2 minus 1 is 1, so slope of 1. So here's my slope of 1. Notice that it's right, see, slope of 1 to the right, 1 up, or 1 up, 1 right. So it doesn't have to be perfect, but there's my slope of 1. So I'm going to go to 2, 2. So at 2, 2, let's see, 2 squared is 4, 2 minus 1 is 1. So slope of 4. It doesn't have to be perfect, guys. There's my slope of 4. I'm going to go again to 0, 1. And let's see, 1 squared is 1, 0. So slope of negative 1. So there's my slope of negative 1. And I'm going to go to 0, 2. 2 squared is 4. So slope of negative 4. So something like that. And there it is. There's your slope field. All right, letter B. Let y equals f of x be the particular solution to the given differential equation with an initial condition f of 2 equals 3. This is a point, guys. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Oh, perfect. Use your equation to approximate f of 2.1. All right, let's get rid of the first question first. Let's answer the first question first. I need two things for a tangent line. What do I need? Yeah, you're right. I need a point and I need a slope. So I already have a point. This f of 2 equals 3 is my point. And I'm going to get my slope. And luckily, they gave me dy dx right here. See, guys? So I have everything I need. So I'm going to write dy dx. And if you want to be formal, you can write a line like so and say 2, 3. You don't have to do this, guys, but it'd be nice if you wrote it in math terms. So this means dy dx is evaluated at 2, 3. That's what that means. So I'm going to plug in a 3. So 3 squared over 2 minus 1. And let's see, 3 squared is 9 divided by 1. So you just get 9. So here's my slope. Here's my point. And I'm just going to use point slope form. So here we go. Y minus 3 equals 9x minus 2. Done. This is your tangent line. Now, what they want, use your equation to approximate f of 2.1. So they want me to use my tangent line to approximate f of 2.1, guys. So I'm going to insert 2.1 for this x value there. So I'm going to say y equals, let's see, 9 times, if I wrote 2.1, I'll just write it in there. 2.1 minus 2 plus 3. If you're scared, you can write it, you can leave it like this, guys. But we're not scared. Let's see what that y value is. 2.1 minus 0.2 is 0.1. Plus 3, so that's 0.9, and then plus 3, so 3.9. I think that would be full credit, but I think the best way is to write a quick statement with mathematical precision here, or mathematical symbols. F of 2.1 is approximately 3.9. I don't see any mistakes. Let me know if I made a mistake somewhere. I make them all the time. Let's see. I think that looks pretty good, guys. All right, letter C. Find a particular solution at y equals f of x to the given differential equation with initial condition f of 2 equals 3. Okay, so now they're wanting me to find an equation when x is 2 and y is 3. So I'm going to take my dy dx equals, so I'm going to write dy dx equals y squared over x minus 1. So the secret here, guys, or the way to do this is you have to separate your y's with the y's, the x's with the x's. So I'm going to divide by y squared to get the y squared over here. I'm going to multiply by dx to get the dx over there. So I have dy over y squared equals 1 over x minus 1 dx. You can put the dx here on the top, but I wouldn't, guys. I would just leave it like so. All right. The number one mistake that we make, by the way, and you have to separate it. If you don't separate it, you're not going to get any points. That's just the way it is. The number one mistake that I've seen kids do is when they integrate, they say that the integral of y squared is ln of y squared. The only time it's going to be ln, you have to have something linear in the bottom. Y minus 1, y plus 2, y plus 5, y minus 7. It has to be a linear, quote unquote, like y to the 1 power minus or plus something. Or it could also be a product, 3y minus 2, 3y minus 2, 5y minus 7, 7y plus 2. But it has to be linear, guys. So same thing here, x minus 1. So that is a linear. So that's gonna be ln when I do the antiderivative. Sorry if I explained a lot, guys, because maybe some of you guys may be a little rusty. So this is the same thing as y to the negative 2. So I would not write that in there. I would just make a note of that in your head. So when you take the antiderivative of that, you're going to get a negative 1 over y equals, and now the antiderivative of this guy definitely is ln. Put absolute value because we do not have any terms at the moment. Well, we will in a little bit. That 2, 3 comma there is going to help us out. Plus c. And then I guess this looks like a good location to solve for c, guys. I noticed that my 2 is bigger than 1, so you can get rid of, well, don't get rid of them yet. I'll show you what I mean. Ln absolute value of 2 minus 1 is 1 plus c, and I didn't even replace the y value there. That's a 3. The ln of 1 is 0, guys. So my c is, semicolon c is 1/3. So here's what I have now. Negative 1 over y equals ln of x minus 1. And that should have been a negative 1/3, right? Minus 1/3. Yeah, everything looks good right there. All right, why did I write parentheses instead of absolute value? Because I know that my x value is larger than 1. Because look, it says right here, x equals 2. And remember, guys, if x is larger than 1, well, I mean, there's no reason to put absolute value because I'm always going to be positive. Does that make sense to you guys? X is always larger than 1. So that's why I'm able to put that parentheses instead of absolute value. All right, we're trying to solve for y. So I'm going to divide everything by negative 1 or times everything by negative 1. So I'm going to put semicolon. I'm going to say 1 over y equals negative ln of x minus 1 plus 1/3. And then from there, this is the same thing as saying all this over 1. So I'm just going to, there's an equal sign here. 1 over y equals that over 1, excuse me. So I'm just going to write y equals, and just, excuse me again, flip everything. So I'm going to write it up here, guys. Y equals 1 over negative ln of x minus 1 plus 1/3, and you're done. You can leave it right there. It is bothering me, this 1/3, and what I would probably do, let's see, 3 over 3. So then I would write maybe, so 1 over 1/3 minus, or let me put all this together now because we have a common denominator. 1 minus 3 ln of x minus 1 over 3, keep change flip, times 3 times 3, so 3 over 1 minus 3 ln of x minus 1. I think I did everything correctly. I don't think I lost a point. That's the same. I like this one better. If you feel that your algebra is weak, you can stop right there, guys. All right, let's keep going. So here we go from 2003, and you'll be surprised. Last year we did this one, guys, and in 2019 there was a question very similar to this one. So hallelujah, I guess. So class of 2019, if you're listening, way to go, guys. All right, so here we go. So we have some type of cylinder here. It looks like it's a coffee pot shaped in a cylinder. I can't recall seeing a coffee pot shaped as a cylinder. Most of them are kind of roundish, but that's fine. Let's just do this question. A coffee pot has the shape of a cylinder with a radius 5 inches, as shown in the figure above. Let h be the depth of the coffee in the pot, measured in inches, where h is a function of time t, measured in seconds. The volume b of a coffee in the pot is changing at a rate of -5 pi h cubic inches per second. Notice what that is, guys. That is your dV/dt. The volume v of a cylinder with radius r and height h is v equals pi r squared h. All right, real quick, that right there is your dV/dt. So the volume v of the coffee in the pot is changing at the rate of that cubic inches per second. And even the units help you out here. All right, I think they're being nice. They give us pi r squared h. They don't have to, but that's fine. Show that dH/dt is equal to negative square root of h over 5. Okay, the way we're going to show that, guys, this radius is not changing, is a constant. So I'm going to plug that in right here into my volume formula. Volume equals pi times 5 squared times h. So volume equals 25 pi h. And now that I know that my volume is this, I'm going ahead and take a derivative of this with respect to time. So I'm going to write dV/dt is equal to 25 pi dH/dt. 25 pi dH/dt. Now here's the kicker. I already have an expression for dV/dt. It's -5 pi square root of h. So what I'm going to do is set them equal to each other, guys, because that's what your dV/dt is. So I'm going to write -5 pi square root of h is equal to 25 pi dH/dt. And I want the dH/dt by itself, because that's what we're trying to solve, see? So I'm going to divide by 25 pi. And there you go. So now I have dH/dt is equal to, let's see, the pi's cancel out. 5 goes into 25 5 times. So a negative square root of h over 5. Cool, right, guys? Yay. I think it's pretty cool. All right, let's keep going. Given that h equals 17 at 0, solve the differential equation dH/dt equals negative square root of h over 5 for h as a function of t. All right, you must separate your variables. If you do not do that, you're not going to get any credit. The h's with the h's and everything else with everything else. There's no t in here, so you're going to just multiply by dt. It's going to be a constant with a dt on it. So I'm going to divide. So here's what I'm going to have. dH over negative square root of h equals a negative 1/5 dt. If you want to put the dt in the top, that's fine, but I wouldn't. So now what I'm going to do, guys, I'm going to rewrite this. I'm going to, and I didn't mean to write the negative there, guys, sorry. So I almost lost the point there. I left the negative with the 1/5. I could have brought it up with the h, guys, but it's easier to leave it with the constant. So there it is. It's left with my constant there, right there. Okay, so I'm going to bring this h up. So I'm going to have h to the negative half, dh equals negative 1/5 dt. And now I'm going to integrate. So when I integrate, let's see, negative half plus 1 is a half, divided by half. So I'm going to have 1 divided by half is 2. So 2 square root of h, so that's h to the half, equals negative 1/5 t plus c. So this feels like a good location to plug in my 0.17. So if I plug in a 0.17, so here's what I'm going to get. So I get 2 square root of 17 equals 0 plus c. So that means, I'm going to put a semicolon instead of arrows. That means that my c is 2 square root of 17. So let's come back, and I'm going to write 2 square root of h equals negative 1/5 t. And then the c was 2 square root of 17 plus 2 square root of 17. So I'm going to divide everything by 2, because what we're trying to do is solve for h, guys. Divide everything by 2, divide by 2, divide by 2. So I have the square root of h equals negative 1/10 t plus square root of 17, and then just square everything. So now my final equation, I'm going to rewrite it. I'm going to write it right here. I'm going to have h, and if you want to write h of t because it's a function with respect to time, is nothing more than negative 1/10 of t plus square root of 17 with a square on it. And there it is. All right, I'm going to do letter C in blue, guys, because I'm taking up a lot of space here. At what time t is the coffee pot empty? Okay, well, that's pretty straightforward, I think, hopefully. So let's think about it. This coffee pot is empty whenever the height is 0. That's the only time it's empty, if the height is 0. So I already have an equation for h of t, so I'm going to set this bad boy up to 0. That's all I'm going to do. I'm going to write 0 equals, and I guess if you square root, that goes away. So I'm just going to go negative 1/10 t plus square root of 17. If you don't want it to go away, you can leave it in there and then put squared, but 0 squared is still 0, guys. And now I'm just going to move that 1/10 t to the left. So, of course, you got to do this without a calculator, guys. So 1/10 t is equal to square root of 17. And then the way to get rid of that 1/10, you just multiply by 10. So t equals 10 square root of 17. And that's it. You're done. I didn't think anything was too extreme there, guys. I think you're going to like those questions. So, yeah, cool. All right, guys, here's this one here from the 2008 exam. Consider the differential equation dy dx equals y minus 1 over x squared, where x does not equal 0. On the axis provided, sketch a slope field for the given differential equation at the 9 points indicated. So only do it for those 9 points and just those 9 points, period, guys. The first thing I would do is I would plug in my slopes where there's 0. And I know there's 0 whenever y is 1. So y is 1 there. So there it is. My slopes are 0 there. Do not put anything on the y-axis because your differential equation is undefined there. So do not put vertical lines. I know you may be tempted, but just put them on those 9 points. Now, make sure that at 1 and a negative 1, those slopes are going to be symmetric, guys. They're going to be the same because I have x squared in the bottom. So let's just go ahead. You'll see what I mean right now. So that point is 1, 0. 0 minus 1 is negative 1. 1 squared is 1. So negative 1 divided by 1 is the slope of 1. And same here with this, guys. Negative 1 squared is 1 again. See, so you get negative 1 again. There it is. So I'm going to go ahead and do 1, 2. 2 minus 1 is 1, and then 2 squared, 2 minus 1 is 1, and then 1 squared is 1, so that's a slope of 1. And this one has to be a slope of 1 as well. So there it is. We got almost all of them. We just need the one at 2, 0 and 2, 2. So at 2, 0, let's see, 0 minus 1 is negative 1, and 2 squared is 4. So negative 1/4. It doesn't have to be perfect, guys. Make it kind of flatter than at 1, 0, but negative. So there it is. And then at 2, 2, 2 minus 1 is 1, and then 2 squared is 4. So it's a positive 1/4. And there it is, guys. I think that's full credit. I don't remember how many points that is. Check out the rubric. All right, find a particular solution y equals f(x) to the differential equation with the initial condition level 2 equals 0. All right, so there's my point, and so what you got to do, dy dx equals y minus 1 over x squared. So you got to get the y's with the y's, the x's with the x's. If you do not do that, guys, you do not get any points. So dy over y minus 1 equals 1 over x squared dx. Cool? Yay, cool. So there's your at least a point right there. Integrate. Now in the bottom, again, y minus 1, linear. Everything's perfect. So I'm going to do ln and do ln absolute value of y minus 1. You do absolute value because we don't have any limits on my integrals yet. And then the antiderivative of 1 over x squared is just a negative 1 over x. And then I'm going to put plus c. Now, it doesn't feel right to plug in 2, 0 here. You can, I guess. I'll tell you why. Because I have these absolute values. And I guess if you look at the 2, 0, yeah, there's no hints there. I would write this as an exponential, and then I would decide, my initial condition will decide whether it's a positive or a negative. So here's what I mean. I want to turn this into an exponential. So I want to get rid of that ln. E. So when you do that, you're going to have y minus 1, you still have absolute value there, equals e to the negative 1 over x plus c. Now remember, side note, when you had x squared times x to the third, that was just x2 plus 3. Now look, x to the fifth. So I can rewrite this, guys, as that is just e to the negative 1 over x times e to the c. And that e to the c is some constant. This is when I'm going to take out the absolute values. So I'm going to write y minus 1 equals c, that's just some constant, e to the negative 1 over x. Why did I take out the absolute values? Because I let my condition determine whether my c is going to be positive or negative. So you need to have your absolute values until at least this step, and then you can get rid of them. All right, so check the rubric whenever you get a chance, guys, because I want to make sure that I'm getting all my points here. I'm going to plug into 0. Let's see, 0 minus 1 equals ce to the negative 1/2. So let's see, I have negative 1 equals, well, I'm just going to write the same statement here. Divide by e to the negative half, divide by e to the negative 1/2. And I get that c is equal to, I'm going to bring this up. So when I bring it up, I'm going to have negative e to the positive half, positive exponent. So here's my equation. Y minus 1 equals negative e to the positive half times e to the negative 1 over x. And when I move my 1, y equals negative e to the positive half times e to the negative 1 over x plus 1. And I guess you could leave it like that, guys, but it's probably going to annoy a lot of math teachers and professors. It'd be full credit right there if you want to stop there. But remember, look, it has the same base, e and e. So that's like saying, here's another side note. It's like saying negative x squared times x cubed. That's a negative x to the fifth. So might as well just fix it. Y equals negative on the outside, e. And then I'm just going to add these two suckers up, guys. So I'm going to write 1/2 plus a negative, so minus 1 over x plus 1. And there it is. That's it. That's my equation. All right, let's keep going. For the particular solution, y equals f of x, described in part B, find the limit as x approaches infinity. All right, let's do that, guys. Limit as x approaches infinity of negative e to the 1/2 minus 1 over x plus 1. So as x approaches infinity, understand that 1 divided by a huge number, this is going to be approaching 0. Just the exponent, the 1 over x part. So what I'm going to have as an output is negative e to the 1/2 plus 1. All right, guys. I hope you enjoyed this video. Hook me up with a thumbs up if you did. I guess if you didn't like it, you can give me a thumbs down. But I really don't want those thumbs down. Take it easy, guys, and take care of my Delta Math and the free response questions that I put on Google Classroom. And that's it, guys. All right, talk to you guys later.